Hello everyone, this is a follow-up with your Lab 3 questions. I'd like to address on the question part 2, question 1. This question is asking to create Thevenin equivalent circuit based on figure 2. I copied the figure 2 here. We see that we have two voltage sources. That's something that may be different to you, and we are asked to determine Thevenin equivalent circuit. To draw that, we have to find R Thevenin as well as V Thevenin. Let's start finding R Thevenin first. To find R Thevenin, you might have already know that we make all the voltage sources wire and current sources open. Since we don't have a current source, we only have to make the voltage sources wire. I draw a sample circuit here. Two of the voltage sources are wire. And the other thing that we have to pay attention is, since our output is over here, we need to look at the circuit from this side. So that's something that's very important. If we look at the circuit from different way, we may have a different R Thevenin. Another way of figuring out if the resistors are in series or parallel will be coloring the wires in any color that is sharing the resistor will be parallel resistors. In this case, for example, I colored with gray and red color, so we can see that R3 are sharing the same color with 10K as well as R2. As we look at this circuit, all of the resistors are sharing the colors. For example, R3 is sharing with R2 black and red as well as R1. So that means all of our resistors are in parallel. So in the next step, we find R Thevenin with the calculation of R3, R2, and R1 to be in parallel. In this case, we basically find equivalent resistor. R3 and R2 in parallel will make 359 ohms. Calculating this value in parallel with R1 give you the final value of R Thevenin. In the next step, let's look at finding V Thevenin. You may already know that superposition means turning off one of the voltage sources and finding the point that you're looking for, and turning on that voltage source and turning off the other one to find the same points voltage and nodal voltage, and combining both node voltages. That should give us V Thevenin. So in this case, let's name this V2 as first case and V1 as a second case. In our first case, we are turning off the V2. When we turn off the V2, we have a circuit looking like this. Now we need to calculate VA. I named it VA1. To calculate VA1 with voltage divider, let's determine how resistor values are aligned. Are they in series or in parallel? The best way to determine that, to color the wires, any color that are sharing the same colors will be considered as in parallel. In the circuit, as we can see, R3 and R1 are sharing the same colors, so these are both are in parallel. Let's combine R3 and R1. When we do the calculations, we find 909 as an equivalent resistor, considering this R3 and R1 in parallel. I draw the circuit and I put the value in. We already have 560 with 5 volts with this voltage source. Now we have only two resistors. It's easy to calculate with voltage dividers, and we find 3.09 volts. Let's do the second case. We turn on the other voltage source while we're turning off the second voltage source, and coloring the resistors shows that R2 and R1 are sharing the same colors in this case. Making another circuit combining R2 and R1, we will have this circuit, equivalent resistor became 532.3. This value comes from R2 and R1 being in parallel and calculating the equivalent resistor. And we already have R3, which is 1K, and from here I labeled this node as a VA2. Defining voltage divider, we find sum of VA and VA2 is going to give us V Thevenin. The superposition is defined the sum of these two voltage. In the last step, you draw your Thevenin equivalent circuit, which will be, and just put the values in.